So if I have A equals some scalar little c times B vector, this is then the two vectors are parallel to each other. A vector is parallel, so that's how we show that, to B vector. Okay, remember perpendicular we would show like that, right? And then I think they're orthogonal or perpendicular if their dot product is 0. So if A vector dot B vector equals 0, remember not 0 vector because the dot product is a scalar, then so if we have this, then A vector is perpendicular to B vector. In other words, they're 90 degrees apart. Okay. So, and why is that? There's a simple proof of this last one. So and we can use our theorem. If we have, what would cosine theta be if they're perpendicular? If they're perpendicular, theta would be 90 degrees, right? Or pi over 2 radians, right? And of course, what's cosine of pi over 2? 0, but that also equals A vector dot B vector divided by the norm of A vector times the norm of B vector by our theorem, right? And then what can we do to both sides? Multiply by that, gets rid of that, so we end up with A vector dot B vector equals 0. So if the dot product of two vectors of the same size is 0, then they are perpendicular to each other. Okay, pretty nice deal there.